Okay, so there's one more type of probability we're going to dive into, but I kind of am separating it out because it's got a few more wrinkles than what we've done before. And it's the idea of using binomial distribution and we use it when there's only two outcomes, right? So I'm going to walk you through an example, and hopefully as we work through it you can see some of what's going on here. So in this example, we're actually going to do lots of examples, but we're going to use this information. We have a 90% free throw shooter. Okay, which means that his probability of a make is 0.9. And his probability of a miss is 0.1. Okay? And we're going to send him to the line. He's going to shoot 20 free throws. Okay. So the first question I have is, what is the probability that he makes all 20? So what's the probability of making all 20? Okay, so that means he goes make. Now every time he steps to the line, these are independent free throws. Just because he makes 10 in a row, it doesn't change his probability for the 11th. Every time he shoots, he's got a 90% chance of making it. So if I'm shooting 20 free throws and I want to make all 20, then I take 0.9 and I raise it to the 20th. And the likelihood of that happening is about 0.122, so about 12%, or almost an eighth. An eighth of the time, if you put him in the gym, give him 20 free throws, he's going to make all 20 of them. So maybe about once a week, something like that. 1 out of 8 times, approximately. So that's if he wants to make all 20, which good for him, more power to him, that'd be awesome. What if, he's a 90% free throw shooter, what's the probability that he makes 18? Well, that gets a little bit different, because if he makes 18, he misses 2. Right? So we have to account for what is the probability of making 18, what is the probability of missing 2. And when we do that, we have to think about how many different ways he can make 18. He could make 18 in a row and then miss 2. He could miss 2, make the next 18. He could make 9, miss 1, make 9, miss 1, whatever. There's a lot of different ways. And the order doesn't matter, right? So this is going to be a use of combinations. So we are going to do 20, and we are going to choose for him to make 18. So now this is just notation, and it's just another way of writing this. In other words, if he goes make, miss, and then a lot of makes, we're not going to say that's any different than him going make, miss, a lot of makes. We just want 18. We don't care about the order. So we're going to use that 20, choose 18. Then we're going to say 0.9 of the time, 90% of the time, he's a make. So that probability, that 0.9, we have to account for 18 makes. And then the other 2, because we still want it to add up to 20, the other 2, he's going to miss 0.1% of the time. So when we account for all that, we end up with about 27% of the time that he's going to do that. Oh, my bad. I wrote that down wrong. Let me fix that quick, because that 0.27 is not quite right. I actually want that to be 0.285. Some bad calculator reading on my part. I apologize. There we go. Looks a little better. So that's the probability of making exactly 18. So now we're going to change the game again. What's the probability that he makes at least 18? Which, if you're keeping score at home, that means he could make 18, which we know the probability of. It means he could make 20, which we know the probability of, or it means he could make 19. So the one I don't know so far is I don't know the 19. So I'm going to set it up. He's shooting 20 times. I want 19 possible outcomes that he makes. He's a 90% free throw shooter, and he's going to make it 19 of them. On the other one, he's going to miss. There's where our 0.27 should have gone. Okay, so now this is not the answer, right? This right here is the probability that he makes 19. Right here, this was the probability, oops. This was the probability that he made 18, and up at the top, this is the probability that he made 20. And the reason I'm accounting for all of those is the probability of making at least 18. Well, to make at least 18, that means I want to account for the probability of making 18 plus 19 plus 20. So I'm going to add up my three fractions. What do I got? I've got 0.122, that's my 20, my 0.285, and no idea why I put the plus right there, that's really weird. And then the plus 0.27. So there's my three choices. And I'm going to add all those up, and the probability of him making at least 18, about 2/3 of the time he's going to make at least 18. You want him at the line. What's the probability that makes less than 18? Or at most 18? Now you could say, okay, but so I have to find the probability that makes 0, that he makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You could do that. You could also make your life easier. Making less than 18 is what we call the complement to making at least 18. He either makes 0 to 17 or 18 to 20. That's all the outcomes. Oops, let's get you so you can see it. So if I know that this is the probability of making at least 18, I can subtract that from 1. And that result, about 1/3 of the time, is how often he'll make less than 18. So that's kind of where it's coming from. To figure that out is we have to use this idea of the complement. Where we're looking at the rest of the outcomes. So anyway, binomial probability, pretty cool. We just have to make sure we account for this part where we show that hitting 18 free throws can happen a lot of different ways, and this number will tell us exactly how many different ways we can do it, and then we can apply that to our probability. So hopefully that gives you some good ideas on how to do binomial. Make sure you ask if you're stuck, and we can get some things figured out. You can do this.